In this unit, we're going to be working with perimeter, area, volume, and temperature. In this lesson, we're going to look at calculating volume. Okay, hi everybody. So in this lesson, we're going to be talking about volume. Okay, and you're probably already familiar with this because you've very likely looked at stuff like this in the past at an earlier class here. But volume is the amount of space a three-dimensional object takes up. And usually what we do with this, and it's kind of a similar build-up that area is, we use linear units, but we think of them in a cubic sense, okay? So just like with area, what we did is we get a sense of what like an inch by an inch is, and again an inch squared. What we do now is we're going to take a look at an inch by an inch by an inch. And so what you do is you get in your head, you know, what that would look like. Sorry, 1 inch, 1 inch, 1 inch. And then we have an idea of how much volume that takes up, and then we basically figure out how many of those could fit in the various shapes that we're looking at. And we can use centimeter cubed and so on. But it's typically going to be a linear unit that we cube, okay? A lot of the formulas that you're going to need are going to be on your formula sheet, and we're going to denote volume by V clearly here. So we're going to just take a look at some examples. It's mostly just getting the right formula for it and then plugging in the pieces that you see from the images that you're going to get. Okay, so let's just dive in and start doing some calculations here. So calculate the volume of the following shapes and then round to the nearest tenth when necessary. So here we go. Our first shape here is a rectangular prism. And when you look up the volume for that, you're going to see that's going to be length, width times height. So let me take a look at this here. It's probably clear that the length is going to be 45 inches. The width will be 12 inches. And the height, 18 inches. Okay, then we just go to our calculator here, and it's going to be 45 times 12 times 18. And when I do that, I get 9,720 inches cubed. Can fit inside this object right here. And don't be surprised when the numbers get big fairly quickly, okay? Volume calculations, they tend to do that. Here, notice by the little marks that we've got on the sides here, we interpret this to be a cube. All of the sides are the same. So the volume of a cube is going to be the side length cubed, which in this case is going to be 3.75 centimeters cubed. So on my calculator here, I'm going to do that by entering 3.75. Then I'm going to use this button right here. Okay, this is going to raise it to the power, to the exponent, I should say, 3. So 3.75 is the length, it's the width, and it's the height. So it's going to be 3.75 multiplied by itself. It's a factor 3 times. Press enter. And then to the nearest tenth, I get 52.7 centimeters cubed. And now finally, I've got my cylinder here. And the formula for the cylinder, I'm going to make sure we look that up here. The formula for the cylinder is going to be pi r squared multiplied by height. Now, I want you to think about the volume formulas that we're going to use, or that we've used in all three cases here. Remember that when you're coming up with the area of a rectangle, that's length times width. And then I multiply by height. And this right here, another way to think about this is side times side times side. The area of the base is going to be side times side, and then we multiply it by the height, which again is the same length as the side here. Pi r squared is the area of the circle, the circular base, and then we multiply by the height. Okay, in most of these cases here, volume is calculated by taking the area of the base and multiplying it by the height. Okay, area of the base multiplied by the height here. So in this case, we've got pi. The radius of that circular base is going to be 4, so 4 meters, and that'll be squared, and then multiplied by 7.5 meters. So I take out my calculator. I'm going to use the pi button. Pi times 4. I'm going to use the square button on my calculator, multiplied by 7.5. And to the nearest tenth. Actually, in this case, when I round that to the nearest tenth, notice that there's a 9 there. It's going to round that up to the next whole number here. So this will be 377.0 meters. And because I am still rounding in the nearest tenth, I'll put 0.0 there. Good, let's take a look at the next one. All right, so we're going to add a bit of a context to this. Kendra's 6 feet long and 5 feet wide sandbox needs to be filled with 6 inches, a 6-inch layer of sand. What volume of sand is needed? And so if you've seen the other videos here, you're going to notice we've kind of gone back and forth to Kendra's sandbox here. So our volume is going to be length, width, height. But we got to be careful here, because if you get into the habit of just grabbing the numbers that you see in a problem, you're very likely going to do this wrong here, because it's not going to be 6 times 4 times 6, because the units changed. It's 6 feet, 4 feet, and then 6 inches. So this 6 inches is a little bit of a problem here, and what I need to do is I need to convert that into feet. Now, the nice thing is we know that there are 12 inches in a foot, and 6 inches is just basically half of that. So I know that this right here is actually going to be a half foot. Okay? Now I can do the conversion here, but if you're comfortable with that, comfortable with the fact that there are 6 inches in a foot here, 12 inches in a foot, then 6 inches would be half of a foot. So here we would make this 4 feet wide. Actually, I don't know why I'm doing it like that. I'm looking right at the number 6 here. Let's just do that again. Okay, so 6 feet for our length, 4 feet for our width, and then half of a foot, okay, for our depth here. And then 6 times 4 is 24, times a half is going to be 12. So this will be 12 cubic feet. Okay, that's how many cubic feet of sand you'll need, or Kendra will need. Next, we got this question here. Mo buys a pack of 24 soup cans. Each can has a diameter of 10 centimeters. Now, as soon as I get there, I think, whoa, wait a minute. I know that my volume calculation is going to be in terms of radius. So I know right now that if my diameter is 10, my radius is going to be half of that. So each can has a radius of 5 centimeters, so don't get tricked by that, and a height of 14 centimeters. What is the total volume of the Superbot? Okay, well, the volume of each can is going to be pi r squared times height. So it's going to be pi times 5 squared times 14. Okay, so I'll go to my calculator. Pi times 5 squared times 14. I'm going to get to the nearest tenth here, 1099.6 centimeters cubed. But I'm going to leave that number on my calculator here, 1099.6 centimeters cubed. And the reason I'm going to do that is because we're not quite done. Because we're asking for the total volume of soup, and we know that there's 24 cans here, so it's going to be 24 cans times that volume here. So 24 times 1099.6. But actually, I'm going to use the decimal that was given to me right there. I'm just going to multiply by 24, and I'm going to get approximately 26,389.4 centimeters cubed. I'm still going to round it to the nearest tenth. Okay. How much greater is the volume of a cube with the sides that are 6 meters than a cube with the sides that are 2 meters? Okay, so how much greater? How much more volume is it? So what we're going to do here is we're basically going to find the difference between them. So we're going to find the volume of the larger, and we're going to subtract the volume of the smaller. Now remember, because these are cubes, it's going to be the side length of the larger one cubed minus the side length of the smaller one cubed. So in this case, it'll be 6 cubed minus 2 cubed. And bear in mind how order of operations works here. We're going to evaluate the cube before we do the subtraction here. So maybe we'll do this in pieces here. 6 cubed is 216. 2 cubed, okay, 2 cubed is going to be 8. And then 216 minus 8 will be 208 meters cubed. That's going to be the difference between them. Okay. So there you go, some examples to give you something to look at to help you work through how to make these volume calculations. Okay, so just before we completely wrap this up here, just some things to think about here. So in general, keywords. When we're talking about perimeter, look for words like around and total length, okay, to indicate that that's what you're doing here. And then what we're going to do is you're going to add up all the sides, or use the formula sheet, because there might be a formula for the perimeter. But when we looked at our examples here, in a lot of cases, that's what we had to do, is just figure out what all the sides were and add them up. And you're just going to have inches, centimeters, feet, and so on as your units here. If we're talking about area or surface area, then we're covering something up. We're painting a surface. We're putting wallpaper on the surface. But remember, it's two-dimensional. It's just that you could have multiple two-dimensional sides to an object. Frequently, you're going to use your formula sheet to look for your area or your surface area. Okay, an area is for a 2D shape. Surface area is for a 3D shape. And remember that for that 3D shape, your surface area, you're probably going to just split it up into all its individual sides and then add those up. And we're dealing with square units, the same linear units, just squaring them now. And then finally, when we're talking about volume, look for words like contents, fill, hold, capacity, those sorts of things. Typically, we're going to be looking at fairly nice shapes, so you can just use the formulas on the formula sheet there. Okay, and we're using cubic units for volume. There are other units that we could use, but we're going to be pretty consistent with just using the cubic units for this particular course.